To draw the Lewis structure of PF3, you first need to find how many valence electrons are available for you to use. Fluorine has 7 valence electrons, and phosphorus has 5 valence electrons. Since you have 3 fluorine, you multiply 7 by 3, and then add 5 from the phosphorus to get you 26 valence electrons. Then, since there are 3 separate bonds, and bonds use 2 valence electrons, you multiply 3 by 2 to get 6, and subtract 6 from 26 to get 20 available valence electrons. Now, you know how many valence electrons you can use. You draw out the molecule with the smallest amount of bonds possible, and add dots until each atom has 8 electrons around it, remembering that bonds count for 2 valence electrons. Then, you add up all the valence dots, not counting bonds, to see if they equal the number of available electrons. 6 plus 6 plus 6 plus 2 equals 20 electrons, so now we have the correct Lewis structure for PF3. To find the molecular geometry, see that PF3 has 3 fluorine coming off of phosphorus and 1 set of electrons. This means it would fall in the tetrahedral category. The name of the molecule with this structure is called a trigonal pyramidal molecule. To find the Lewis structure and molecular geometry of PF5, repeat the same process.
Phosphorus trifluoride is a polar ion. The electronegativity of polar ions is a difference between 0.4 and 1.8. The electronegativity of fluorine is 3.98, and the electronegativity of phosphorus is 2.19. The difference of this is 1.79, which falls in the category of polar molecules.
For the first problem, NF5 does not exist because it is too polar to be stable, the ionization energy is too high, and nitrogen cannot use d orbitals in bonding to accommodate for the extra electrons. Since phosphorus and nitrogen both have 5 electrons in their outermost shell, they need 3 electrons to complete their octet. But because nitrogen cannot use d orbitals in bonding, NF5 does not exist. Then on to the second part. AS5 does exist because AS has a d orbital which can accommodate for the extra electrons.